All right, so welcome to the sky this month for October 2021. I'm starting this presentation with a picture I took of the sun, unfiltered, on Monday. I was out birding and the sky was cloudy, as it has been for, seems like forever. I happened to look up and realized I could probably capture some of the sunspots on the face of the sun if I took a shot. This shot is unfiltered, meaning I just pointed and shot in full manual and realizing that the cloud was dense enough that I could do it safely. However, this is one of those do as I say, not as I do, or don't try this at home moments. If you don't know exactly what you're doing, then I'll let you know in a sec. Just the safer way to do this is the way I recommend for everybody. But here I've zoomed in on my picture at the top, and the pictures at the bottom are the same, just one is zoomed in a bit more. And this is the Solar Dynamic Observatory. This image is from within, I think, about 2 minutes of when I took mine. So I took my image and then went online and downloaded this to my phone. So you can see it nicely mirrors the sunspot group here and the large one, which had just appeared the day before on the limb of the sun. So there's a lot of solar activity going on right now. I've done a fair amount of solar observing with my actual hydrogen alpha telescope, and it's been really interesting. Battery is running low. Oh dear, hang on a sec. Just hang on. Technical difficulties for it. Here we go.
Matt,
We're good. We're good.
You got to hang in there with us at least until the end of your presentation.
I know, but there was only 10 minutes left on my battery. Apparently, I didn't have it plugged in since we had a power outage just before the meeting started. Anyways, so there is a safe way to do this during the daytime. The first thing to realize is you should really have a filter on the front of your camera. They're called white light filters. Some are for visual and photographic, and some are photographic only. I would recommend getting the visual/photographic one, because the ones that are just photographic let some harmful rays through. So if you happen to look and do something wrong, you're going to damage your eyes. So get the better filters. You can see here they're using their live view screen. You do not ever look through your viewfinder here, okay? Because when you do that especially on a digital SLR, you're looking right through the lens directly at the sun. And if you're really lucky, the worst thing that will happen is you'll burn out the sensor in your camera, and the worst thing is you'll blind yourself. So just don't do it. Use the live view screen, filter it, and then you can take as many pictures as you like. Here's an example of a glass filter made by Thousand Oaks. These are really high quality filters. They're in the range of $100, but they last a long time. They don't get pinholes in them very often. They tend to be really good. The other type, of course, is Mylar, and that's the type of thing you see in those solar eclipse glasses. But people like Baader make sheets of Mylar that you can then turn into custom sized filters for your camera equipment or small telescope. The other, I think we're going to talk about a couple of the missions that are either on their way or about to leave. This first one is Bepi-Colombo, and it's finally arrived at Mercury, sort of. So Bepi-Colombo's been en route for a couple of years. As it dives deeper and deeper into the solar system towards the sun, it's moving faster and has to find a way to slow itself down. So the way it does it is by doing flybys of the Earth first, then Venus, and then Mercury until it finally comes into a stable orbit. This particular probe is named after Giuseppe Colombo. I looked this up because I thought it was an interesting name for a probe. And he was a scientist, mathematician, engineer, and he was the guy who first proposed how to do interplanetary gravity assist maneuvers, otherwise known as slingshot maneuvers, which allows you to change your direction and your velocity of your probe to make it go where you want to go. And the cat is drinking my water out of my glass right beside me. This is very weird. So what are the objectives of this? Well, We're going to study the origin and evolution of a planet close to its parent star. Of course, it's very handy. We have planets close to our star, and they're not that far away. We're going to look at the structure of Mercury, geology. They're going to look into the atmosphere, including how it's created and how it escapes from the planet. There's two possible ways it can be created. One is from the solar wind, from the sun, and the other is by the decomposition of materials at the surface of the crust, which then release atoms and create a very tenuous atmosphere. Nothing like anything we would even think of as an atmosphere, but it's there. And then they want to know how fast it's escaping, for instance. And the other thing is this probe actually breaks into two different probes. One, the magnetic field and magnetosphere probe, stays very close. The other one, which is studying the geology and the atmosphere and stuff, has a wider elliptical orbit. So what is the difference between a magnetic field and the magnetosphere? Well, the magnetosphere is the region of space around the planet that's affected by the magnetic field. So whenever you see a picture with all those magnetic field lines around a planet, or similar to iron filings, when you see a magnet, they put the iron filings, blow it up to planet size, right? Those magnetic fields work in a volume of space, and that is the magnetosphere. So this particular probe took off in October 2018. It made its first planetary flyby back in 20, and then it did 2 Venus flybys in 20 and 21. And just on October 1st, it did its first flyby of Mercury. So after that, it has another, let's see, 1, 2, 3, 4, 5 flybys to go all the way through January of 25. And then at the end of that year, around Christmas, it's finally going to settle into orbit around Mercury. At that point, it will really start doing its data collection and everything else. And end of mission is 1.5 years. After that, possibly 2.5 years. It depends on how the probe survives in that environment that close to the sun. Now, what's really interesting is once you start thinking about these orbital mechanics and how does the heck does you get this probe to go in there, do all the flybys, and how do you get it to settle into orbit? Turns out if you go to that page from the European Space Agency, because it's them and the Japanese that are actually co-working on this probe, there's an icon here, interactive, where is Bepi Colombo? And if you go into that, you get something like this. And what it does is green line is where the probe is moved through space to where it is now from the Earth. What you can do is you can take this slider and move it all the way back to the beginning and then hit play. And if you have about 20 minutes, you can watch it as it goes through the changes in its orbit and spirals down towards Mercury. If you don't want to take that long, hit this button here, the setup button, and up here will be a slider. Push the slider all the way to the right. It says speed, and then hit the play button. And it will do it in a much more compressed time frame, but still easy to watch. And as the probe spirals in towards Mercury, you can use your mouse and zoom in to see the elliptical orbits and how they start to merge with Mercury as it goes along. Another mission that hasn't launched yet, but will very shortly, is called Lucy. And this one is the first mission from Earth to go to visit the Trojan asteroids around Jupiter. So Trojan asteroids are asteroids that share the same orbit as a planet. In this case, there's Jupiter, and there's Trojans that are ahead of Jupiter in its orbit and trailing. And there's a huge number of them here and here. This is the inner solar system. That little red dot's Mars, by the way. So the name for this probe, Lucy, comes from that skeleton that they found back in Africa in '74. I think a lot of us remember when that was found and it was announced to the world. And that was a very, very old skeleton that gave us some insight into human evolution. And Lucy is going to look into the evolution of our solar system, and that's how it got its name. Throughout the period of the whole mission, it's going to look at 8 different asteroids. One is in the main belt, which is that belt of asteroids between Mars and Jupiter. And the other 7 are Trojans ahead of and trailing Jupiter itself. And the reason they want to look at them is because those asteroids are believed to be remnants of the material that created the solar system in the first place, or from which the solar system was created. If you want to watch the launch, it's going to be on October 16th. Coverage starts at 5 a.m. and I believe the launch is at about 20 to 6 in the morning. So the reason you can have Trojans that stay in a stable orbit along with the planet is because they're at spots in the orbit called Lagrange points. Now, for any 2 bodies in the solar system where one orbits the other, you can have these Lagrange points, 1, 2, 3, 4, and 5. It only works if the body at the center is massively bigger than the next body. So the ratio of the mass has to be a minimum of 25 times. So, you know, the Earth compared to the sun, it's no problem, right? So here's the Earth, here's the sun, here's these Lagrange points. We tend to put satellites at L1, L2. And the nice thing is that L1 through L3, you can put a satellite there. And even though it's not exactly stable, it will slowly drift away from the Lagrange point. It takes a minimum amount of propellant to keep the satellite in position. And so you can have your missions last much, much longer than if they were just, you know, floating around at a non-Lagrange point. 4 and 5 are different. They're called stable points. And anything within this region of space, here or here, will tend to stay there for long, long, long periods of time. Now, if you've got multiple objects within one of these groups of Trojans here, they will move around with respect to each other, but they will tend to stay in their group. So you can have Lagrange points for the sun, Earth. You can have them from the Earth to the moon, or from the sun to Jupiter, for instance. Every planet versus the sun basically has its own Lagrange points. And here is a little animation of how it actually looks. The inner solar system there, the red dot's Mars. The asteroid belt, the main asteroid belt, would be in here somewhere. And these are all the Trojans trailing and leading that are ahead of and behind Jupiter in its orbit. So Lucy is going to visit both clusters, and it's going to look at 3 different types of bodies within those clusters. 2 of them are dark red asteroids, similar to those found in the Kuiper Belt. In fact, probably very similar to the one that New Horizons took photos of a couple of years after it passed Pluto. The 3rd type they expect is going to be more like the main asteroid belt between Mars and Jupiter. So really, they're just trying to image these things and find out what they can chemically, whatever they can about them while they're running through the Lagrange point. Here is the actual mission summary. If you think about it, it's from when it leaves Earth to when it gets out to the Lagrange point here, L4, and it's going to look at a few different Trojans in here, or asteroids, and then it's going to come zooming around and look at least one over here. The interesting thing is this isn't random. These dots are specific asteroids within that belt, and that one over there is specific. So it's really interesting that they can be that precise in what they're going to do, and it should be a really interesting mission. Unfortunately, it'll be a while before it gets there. And a little bit about the sky this month. There's a lot of information. Bernie posted a ton of information in the event horizon this month about objects to look at all through this fall. Joanne's got a few that she mentions as well in her really good article that she wrote this month. And there's a couple of things in mind. But what I wanted to really talk about was how nice the sky is at this time of year if the clouds ever actually go away. So if you go out at about 10 o'clock at night, anywhere 9, 10 o'clock at night, into a nice field with good horizons, and you look out to the west, you're going to see the Milky Way coming out of the ground there, and you can follow it all the way, almost completely, like directly overhead, all the way to the east, the eastern horizon. So take your time, grab your binoculars. It's just awesome. You can sit back and just scan from basically the core of the Milky Way here all the way out to the outer reaches of the Milky Way over here. So the core is what you see in the summer, right? That's that beautiful Milky Way shot you get with Sagittarius and Ophiuchus and that kind of thing there. So that's why it's really dense. There's all this material, clouds of dust, gas, stars, clusters, all sorts of things, right? But as you move across the sky, you're actually turning away from the core and looking out towards the rim of the galaxy. And so the amount of material is much less, so the Milky Way is much thinner, or there's less material there to see, but it is still there. And even in the winter, the Milky Way is still there. It is just not as obvious as in, say, July, when it's really amazing. Now, tomorrow night, just after the sun sets, you're going to be able to see the moon about 3 degrees away from Venus. The moon's going to be lit about 16%. You should be able to see some earth shine there. And one really nice aspect of this is that the libration of the moon, almost said libation, that'd be wrong. The libration of the moon is such that Mare Crisium, the Sea of Crisis there, is nicely separated from the limb and the terminator. And that's a sort of area that I don't think a lot of people look at enough. When I look at it through my binoculars, the crater rim, because really, even though they call it a sea, it's in a massive crater, right? It's very 3D. You can actually see the mountains around the rim differentiate themselves in 3D from the base, and that's just binoculars. If I zoom in here, you can actually see Mare Crisium much better there. There's a few of these seas that are around the corner, so to speak. What is it called? Mare Smith and Mare Marginis, the sea on the margin. They're there. You can catch a glimpse of them. Have a look at this, though, because when you actually get in close, there's a ton of detail here. So things you can see with the telescope are these ridges here, which are basically lava flow ridges, molten rock that's flown and then just caused this sort of a ridge as it ends. You can see where it's gone out the crater wall and has escaped over there. You can also see in Mare Crisium quite a few craters that have been filled by these flows here, there. There's quite a few of them. If you look around, they're almost completely been annihilated or submerged by the lava. And there's a few obvious ones like this one here, which I happen to remember is called Picard. That is very obvious. And then of course, look at all of the detail and all of the structure around the edge. I think with a telescope, you can have a pretty good time and the lighting will be very nice with this phase. The other thing I wanted to mention is that last third of the month, roughly from the 21st to the 31st, Mercury is in a really good position to view in the morning, and it's even not at too bad a time. Somewhere between around 7 o'clock in the morning, Mercury will be about as high as it gets, where you can see it before the sun peaks over the horizon. So the sun right now in this image is right there. The reason this works so well is because the plane of the ecliptic is very steep in the morning here in the fall. So when the ecliptic is very shallow like this, the sun will be up, Mercury will be up and very hard to see. But right now the sun is behind the horizon and Mercury is there right at the edge of the light dome, and you should be able to see it quite nicely. It'll only be about 8 or 9 degrees up above the horizon, so you do need a clear view to the east, but it will be there. And from what I've read, it's the best view you're going to get this year of Mercury. So, 7 o'clock's not too early. Take the chance if you can and see if you can spot it in the east, maybe take a picture. And that's it. Thank you.